So I've set up my equation based on what I know. Rate times time equals distance. I have two people, Beth and Willie. I have filled everything out that I know in these first two columns. Beth is going 50 miles an hour for 4 hours. He's going 45 miles an hour. We don't know how long. Multiply across, we've got this column. We look up here and see opposite direction, total miles apart. We are going to take those two distances and we're going to add them. What is 50 times 4? Right, so we're going to say 200, and we are going to add to it this second distance, which is 45 times t. And those add up to equal the total distance apart, which is 335. And now we have a pretty basic equation that we can solve. We're going to subtract that 200 from both sides. 45t equals what? 135. How do I solve for the time? Divide. So I'm going to divide 45 on both sides. What is 135 divided by 45? 3. What did I solve for? Look back at my chart and find that variable. What did I solve for? The time for who specifically? Willie. So I solved for the time that Willie drove. He drove for 3 hours. What I want to do is I want to look at that question. Find the number of hours Willie drove. I solved it. I'm done. All right. So you want to make sure that if it had said, how far did he drive? Well, I would have to plug that into 45 times 3, right? Make sure you answered the question when you read that final question. You want to set up a chart for each one of these. You want to create a chart, and the distance, rate, and time ones are always going to be the same. We're going to have two things traveling. We're going to label those two with that first column, rate, second column, time, third column, and then distance. So let's read this one and see what we have. A cruise ship made a trip to St. Vincent and back. The trip there took 6 hours. The trip back took 5 hours. What was the cruise's ship average speed on there if it averaged 18 kilometers per hour on the return trip? So this is a there and back problem, and that's how I usually label these. I label them there and back. All right? So now I'm going to fill in what I know. So yes, this is a round trip problem. For round trip problems, what do I do with those distances? I set them equal to each other. So I'm going to figure out what I know. The trip there took 6 hours. So I'm going to read through here. Cruise ship, there and back. The trip there took 6 hours. Where is that going to go on my chart? That's going to be there, and which one? Rate or time? Yeah, time. So there is going to be 6 hours in time. The trip back took 5 hours. That's also time. That's back. What was the average speed on the trip there if it averaged 18 kilometers on the round trip? Where does that 18 go? Rate for back, right? On the way back. So what I don't know is it's asking, what was the ship's speed on the trip there? This is the variable that I do not know. All right. So how do I find that third column? Always multiply across. This is going to be 6 times r. This is going to be 18 times 5. All right. So I am going to set those equal to each other. That's how I've already established that I need to solve this one. So I'm going to say 6r equals, what is 18 times 5? That is going to be 90. All right. And then how do I solve? What do I do? Divide by 6. What is 90 divided by 6? 15 kilometers per hour. Find that on your chart. That 15 kilometers per hour is your rate there. Is that the question they were asking? Yes, it was. I am done with this problem. We're always going to start with a chart. All right, we're going to take it and we're going to set up what we know and solve for what we don't know. All right, so for this one, it says a passenger train left Washington, traveled towards the repair yards 10 hours later. A cattle train left traveling 70 kilometers per hour. in an effort to catch up. After traveling for 4 hours, the cattle train finally caught up. Find the passenger train's average speed. All right. So we're going to figure out what we have. We have same direction. So this is same direction. They are catching up, which means what am I going to do with those distances? Set them equal to each other. All right, we have 2 types of trains. So I will typically label those just as such, a passenger train and a cattle train. All right. I'm going to read through. A passenger train left Washington and traveled toward the repair yards. 10 hours later, a cattle train left traveling 70 kilometers per hour in an effort to catch up. For right now, this 10 hours doesn't help us, right? Because it just says later. How about this 70 kilometers per hour? Which one is it talking about right now? The cattle train left traveling 70 kilometers per hour. That goes where? Cattle and rate. After traveling 4 hours, the cattle train caught up. Where does that go? Those 4 hours. Who is traveling? The cattle train. That is the cattle train's time. All right. So here's the thing. Now we're going to go back. We have 2 blanks going on. It's asking me a question in the next one. Find the passenger train's average speed. Which box is that? Passenger's rate or time? Rate. So that's where my variable is going to go. Clearly, I don't know that one from my problem because they just asked me that question, right? So I'm going to go and put that variable in. But now I have a problem. I have something else there. So when you have another box, go back to your problem and say, did they give me a context clue? All right, whether it's 2 rates missing or a rate and a time missing, go back. They mentioned time earlier, right? 10 hours later, the cattle train left traveling 70 kilometers per hour. All right, which means how long had the passenger train been traveling when the cattle train left? 10 hours. The passenger train left and traveled for 10 full hours before the cattle train did. But that's not the total time it traveled, correct? 14. It traveled 14 because we know that it traveled for 10. Then the cattle train left and they both traveled additional 4 hours, which means the passenger train traveled a total of 14 hours, okay? So you have to read your problem. It did not say it traveled 10 hours. It said it traveled 10 hours longer than the cattle train. Well, the cattle train traveled 4, which means it traveled 14. So read your problem before you just start filling stuff in. Make sure you know what it means. When you see 10 hours later the first time, that doesn't help you until you have finished reading that whole problem. How do I get that third column? Always multiply across. So this is 14 times r and this is 70 times 4. Because it is same direction, we've already decided we're going to set those equal to each other. So we have 14 times r equals, what is 70 times 4? 280. How do I solve for that? R? Divide. Yes, 280 divided by 14. R equals what? 20. And we're talking about kilometers per hour. Go back to my chart. That R represents the passenger train's rate. That's what they were asking for, so we are finished with that problem. All right, once again, we do want to set up a chart, but this one's going to look a little bit different, all right? So leave a little more room for this one. You do have to title the chart. We do have 2 substances that are going to be mixed. So a first substance and a second substance. And then the final thing is always going to be our final mixture. Final mixture of some sort. All right. Within that, you have units, like you're measuring it somehow. Then you have either dollars and cents or percentages. And then you have this final column, which is going to combine the 2. So let's read this. Eugene wants to make 12 gallons of a 35% alcohol solution. Let's read that first sentence. He wants to make. Is that going to be something he's mixing or his final? His final. He wants to make it. So this tells us a lot of stuff. Gallons. Well, this is the gallons of solution here. All right. 35% alcohol. Well, that tells us what percent we're talking about. This second column is going to be percent of alcohol. All right. The third column always combines those two. This third column is going to be gallons of alcohol. So that's how you're going to figure out how to title these. What units is it measuring your solution in? Percent of what? And then units of that, whatever we had a percent of. Wants to make 12 gallons. Where is that 12 gallons going to go? Under the first column, the last row. That's what he wants to make. 12 gallons. 35%. That is his final solution. That's what he wants to make, right? That's my 35%. All right. So far, so good? All right, let's look at the next line. Mixing together a 90% alcohol solution and a 30% alcohol solution. Those are my two mixtures. You can label it however you want. I typically go 90% solution and 30% solution because that actually tells me what to put in my second column as well. Okay? So this is really easy. If this is a 90% solution, what percent alcohol am I going to put here? 90, right? So these follow what I'm mixing together. All right? So I have accounted for the 90%. I've accounted for the 30%. It says how much of each solution must he make? Do I know how much of the 90%? I do not. So I'm just going to put a variable there. All right? I do know the total is 12. So let's say that first x there was 4. What would the second one be that I don't know? 8. What did you just do to get 8? 12 minus 4. So if I have x, I'm going to say 12 minus x. Anytime they give you the total amount and you don't know either of the other two, it's going to be a variable and the amount minus the variable. All right? The amount minus the variable. Okay? Because that column right here should always add up. X plus 12 minus x equals 12. All right? This column will always add. This second column will never add. Don't add this second column. All right? Don't add. You either fill it in or you don't know it. Okay? You fill it in or you don't know it. You do not add to get that one. How do I get each block of that last column? What do I do across? Same as distance, rate, and time? Multiply. But I don't put percentages. How do I write percent when I'm doing algebra? What do I do with those percentages? Decimal. So this is going to be 0.9 or 0.90. It doesn't matter because it's a 0. This is going to be 0.3. When I have a plus or minus, what do I need to make sure I put around it? Parentheses. And this is going to be 0.35 times 12. All right? Now this last column always adds down. So this is how you get your final equation. The first and second block always equals the third block. That's how we get our equation for these. So I'm going to say 0.9x plus 0.3 times 12 minus x equals 0.35 times 12. All right? Now we're going to treat this just like we would any equation. We're going to distribute, combine our like terms, subtract any numbers over, and then divide. All right? So leave the 0.9x alone. Distribute 0.3. What is 0.3 times 12? 3.6, right? And then 0.3 times negative x is negative 0.3x. What is 0.35 times 12? So we have 4.2, all right? Again, you have your calculator. All right, combine your like terms. Like terms are 0.9x and negative 0.3x, which give me what? 0.6x plus 3.6 equals 4.2. All right, what do I do here? Subtract what? 3.6. Subtract my 3.6. All right, those cancel. 0.6x equals, I heard it over here. I thought I heard it. 0.6, right? Divide both sides by 0.6. What does x equal? X equals 1. Go find on your chart. Where is the x? Where is the x on your chart? Gallons of the 90%. So I have 1 gallon of 90%. All right? It has to add up to 12. How many gallons of 30% do I have? 12 minus the 1. 11 gallons of 30%. And that is my answer. All right. The other thing you'll see is dollars. So instead of percentage, you'll see dollars, right? The setup is exactly the same. We are going to set up a chart. We're going to label it, instead of with gallons and percents, we're going to label with whatever units and dollars, all right? And so it's going to be very, very similar. It's just dollars instead of percentage. You're still going to be mixing two things together. You're still going to have a final mixture. And you're still going to multiply across to solve. So this is going to be my final mixture, just like it was. In this case, what is my units? It's not gallons. How am I measuring this particular thing? Ounces. And now it's dollars, not a percentage, right? Ounces, and it's dollars. And this is dollars per ounce, and this is total cost. Total cost is over here, okay? So let's read through and see what we have. 8 ounces of Arabica, I don't know. Arabica? We're just going to say Arab coffee. Our first type of coffee, right? 8 ounces of that, which costs $13 per ounce. We're combined with 10 ounces of Robusta coffee, which costs $4 per ounce. So we have two things, right? We have our first coffee here, which we can't pronounce, but that's okay. And then we have our second coffee. We're all good. All right. How many ounces do we have of the first coffee? Do we know?
8 ounces.
8. That's going to go first column, first coffee, which cost $13 an ounce. Where's that going to go? The second column of that first coffee. All right. Keep reading. Combined with 10 ounces. Where's that going to go? Robusta, 10 ounces, which cost $4 an ounce. Where's that going to go? Second column, second coffee. All right. Let's look at this first column. I always add down. How much do I have of my total mixture? 18. I never add down here. I do not add down. That is not 17. In fact, look at my question. Find the cost per ounce of the mixture. That tells me I don't know that. I don't know that, right? So I'm going to put a variable there. How do I find the third column? Always, for every single one of these. So this is going to be 8 times 13. This is going to be 10 times 4. This is going to be 18 times x. Just like in every other problem, the first two blocks of this this last column will always equal the bottom. So I have 8 times 13, which is what? 104 plus 10 times 4, which is
40.
equals 18x. What do I do on this left-hand side? I'm going to add 104 plus 40 is...
144.
How do I solve for x? Divide by 18. What is 144 divided by 18?
8.
It is 8. Go find what that represented. That represented the cost per ounce of your mixture. Is that what they were asking? Yes, it was. We are done.